Hello everyone. Let us get on to the next topic, that is respiratory volumes and capacities. So this is a definite NEET question. Very important for your NEET exam, sure short question. Now, there are lots of confusions that I have seen among students that they find very difficult to understand volumes and capacities. So I would just like to tell one thing. These are all experimentally determined values. So if you get into a hospital or a laboratory diagnostic center, you will have a section called as PFT, pulmonary function test. So there are some parameters that can assess the status of the lung, whether our lung is normal or abnormal, in what way it is abnormal, by what terms it is abnormal. We will be able to make out everything if we do a PFT. And the device that we commonly use is something called as spirometry. So this spirometry, it's a device that is used to calculate the respiratory volumes and capacities. So it's like volume, I try to quantify a single entity. Capacity is I try to put everything together. For example, say suppose this is an auditorium. I have divided into many sections. Say suppose section 1, section 2, section 3. Section 1 can accommodate 50 people. Section 2 can accommodate 50 people. Section 3 can accommodate 50 people. But what is the total capacity of my auditorium? It is 150. The same concept here. Volume is I try to define or quantify a single entity. But when I add different entities or the volumes together, I finally arrive at a capacity. This is the basic thing that you must know. More than this, what you need to understand, all these were experimentally found values. We'll get into the topic now. Okay. Now, we have got 4 respiratory volumes and 5 respiratory capacities to be studied. Right? There were 4 respiratory volumes and 5 respiratory capacities that we need to look into for your exam. So, your questions can be in terms of either definitions or match the following, wherein they ask you some values. Right? So, what are the 4 volumes? The first one is your tidal volume. First one is your. So we have got 4 respiratory volumes and 5 respiratory capacities. So what are the 4 respiratory volumes? So the first one is called as tidal volume. The second one is called as IRV or inspiratory. I'll try to put it in short. Inspiratory reserve volume. The third one is ERV or called as expiratory reserve volume. The last one is residual volume. So inspiratory reserve volume, expiratory reserve volume, residual volume, and first one is the tidal volume. So please understand, the definitions will be very confusing, but if you try to understand what we're actually trying to do, you need not mug up the definitions. As I said, it is a part of PFT. So any test you do or anything you do on a patient, what is the first thing that as a doctor we all will learn is you should convey every single instruction very clearly to the patient. So we have got something called as patient-doctor communication skill. That is very important. So we need to communicate every single thing properly to the patient. So when I'm trying to assess the functioning of his lung, I'm going to do something. I'm going to measure all these. Then I need to give him some instructions. What instruction I'm going to give is the definition. Tidal volume. So what instruction I'll give is, man or sir or madam, just take in air normally. Inspire normally. Expire normally. So we'll just say in a calm situation. So like while we sleep, we breathe. While we eat, we breathe. And similarly, if you're listening to my lecture, you will be breathing. So during a routine life, how you are breathing, do the same. So tidal volume is I try to measure the amount of air that a person can either inspire or expire by means or by during a normal course of a breathing. That is called as tidal volume. So if you take, we'll try to come to the values at the end. First, I'll try to give all the instructions. Next one, inspiratory reserve volume. Now, inspiratory meaning I'm going to ask the patient to inspire. As I said, my definitions will carry two things. I give him some instruction and also a condition. You do this, but I need this, right? It might confuse you, but this is how it is. So I'm giving instruction to my patient to inspire. But what is the condition I'm giving him is do it forcefully, meaning by means of forceful inspiration. By means of forceful inspiration. So the amount of air a person is trying to inspire by means of a forceful inspiration is called as inspiratory reserve volume. Is called as inspiratory reserve volume. Now, what is expiratory reserve volume? Same thing. Amount of air a person can expire. I ask the patient to expire following a forceful expiration. Following a forceful expiration. That is called as expiratory reserve volume. Residual volume is I'm trying to calculate the amount of air present in the lung. Amount of air present in the lung after forceful expiration. Residual means what? Residue. So what is the residue of air present after a forceful expiration in the lung? That is called residual volume. So we have got basically four volumes: tidal volume, inspired reserve volume, expired reserve volume, residual volume. So I have given the instructions to the patient clearly. Now I am supposed to find out the values. So the normal value of tidal volume is about 500 to 600 ml. So when we are calm, when we are so polite, we try to give out 500 to 600 ml or take in 500 to 600 ml of air. Inspired reserve volume is about 2500 to 3000 ml of air. All these you need to memorize. These are all fixed values. Expiration 1000 to 1100 ml of air. And residual volume is 1100 to 1200 ml of air. So these are the different residual volume, respiratory volumes that you must know. So 500 to 600 ml, 2500 to 3000 ml, 1000 to 1100 ml, 1100 to 1200 ml. These are the volumes. When I try to add everything, I get capacities. So I have got 5 respiratory capacities. That is very important for the exams again. So I'll list down everything first. So the first one is the inspiratory capacity, IC. Second one is expiratory capacity. Third one is functional residual capacity. Fourth one, vital capacity. And final one is the total lung capacity. These are the 5 respiratory capacities we have. So as usual, we'll try to look at the definitions first. Inspiratory capacity. So again, instruction, condition. What I do here is I'm a very clever person, you know. What I will do, I'll ask the man or the patient, sir, you inspire. Yes, that's absolutely fine. But what you're going to do now is you inspire the air after a normal expiration. What was inspired reserve volume? Inspiration after forceful inspiration. You do a forceful inspiration. As a result of forceful inspiration, what is the amount of air that you are inspiring? It is called what? Inspired reserve volume. But when I say inspiratory capacity, amount of air that the patient can inspire after a normal expiration. What is expiratory capacity? Amount of air a person can expire after normal inspiration. Now let us look at the formula. If you take inspiratory capacity, normal expiration, so tidal volume, inspiration, so I try to measure the inspiratory reserve volume. So tidal volume plus inspiratory reserve volume is inspiratory capacity. So if you look at the value, it will be approximately between 3000 to 3200 ml, I can say. Sorry. It can be somewhere between 3000 to 3200 ml. So in early 3000, okay, 3500 ml also I can say. Expiratory reserve volume, expiratory capacity will be tidal volume plus expiratory reserve volume. Expiratory capacity, so expiratory reserve volume. So it will be around 1600 to 1900 ml. This is the range. So late thousands, it is expiratory capacity, right? So inspiratory capacity is tidal volume plus inspiratory reserve volume, that sums around 3000 to 3200 ml. Expiratory capacity is TV plus ERV, that sums around 1600 to 1900 ml. Next one is functional residual capacity. So what is residual volume? The amount of air that residues or that is present in the lungs after a forceful expiration. Here it is the amount of air that is present or the left out or as a residue in the lung after a normal expiration. After a normal expiration. So if you look at the formula here, we'll be having residue, so residual volume, so RV plus ERV. So if you look at the value, it will be somewhere around 2200 ml to 2400 ml. So approximately in early 2000s. So late 1000 expiratory capacity, early 3000s inspiratory capacity, early 2000s functional residual capacity. Next one, vital capacity. This one is the definitions of inspiratory capacity and expiratory capacity combined, but the condition will be different. What I'm trying to tell, what is the definition of inspiratory capacity? Amount of air that you will inspire after a normal expiration, right? Here it is just the ulta way. Amount of air that you can inspire followed by a forceful, not a normal expiration, but instead a forceful expiration, or it is amount of air that a person can expire followed by a forceful inspiration. So I will give the instructions accordingly. If suppose a patient is comfortable with inspiring more than expiring, I can ask him to do this process. Okay, depending on the patient condition, I can ask him to do any of this. So amount of that he can inspire followed by a forceful expiration, or amount of air that a patient can no expire after a forceful inspiration, it is called as vital capacity. So what is the formula to calculate vital capacity? Yes, I'm going to do a max now. It is TV plus IRV plus ERV. Since it involves both components, I can take either of these. Now, I'm going to rewrite this as inspiratory capacity plus ERV or expiratory capacity plus IRV. This is very important question. So in your NEET exams, they are giving these formula and they are asking you to calculate the vital capacity. So sometimes there is this clinical case questions and they're asking you to do all this. So how I have derived, we all know TV plus IRV is IC. TV plus ERV is EC. So I have done like this. So these two put together, we get EC, right? And the last one is total lung capacity. For total lung capacity, it is the sum total of all the volume. So this, for vital capacity, the value will be in early 4000s. So I can say 4000 to 4400 ml or so. Total lung capacity is sum total of everything, so approximately 6 liters. So it is RV plus ERV plus IRV plus TV. So if you add everything, approximately you will get 6 liters. Cardiac output 5 liters, total lung capacity 6 liters, right? So these are the things that you must know for your exam. So they can ask you in match the following, they can just give you the values and they can, on one column you will have the values, on the other column you will be having the names of capacities and volumes, or they can give you a definition. So please be very thorough. So just have to know that where I am giving a condition of normal situation, where I am giving a forceful. If you know this, your topic is very simple. So I hope I made it clear. I'll meet you in the next video. Thank you. Tata. Bye.